Welcome to Amateur Redneck Workshop. I'm Harold, the resident redneck, and this video we're going to work on the HMI for my power quill feed, HMI meaning human machine interface, and hopefully we'll have a good outcome to the project. I think it ought to work out all right. I've got an Arduino, I've got an Adafruit LCD display, and I've got the internet to answer my questions if I'd have some, so it should work out okay. A lot of people have asked me, what do you got to go and use a touch screen and all that sort of thing for? What's wrong with buttons and switches and stuff like that? And well, what's wrong with buttons and switches is they got to have at least 2 wires for every one of them. And pretty soon you got just a whole gob of wires running everywhere, whereas doing all the work in software and telling it yes, no with just a couple of wires is a whole lot better, simpler. At least to my way of thinking, it's simpler than having to run a whole bunch of dang wires. You'll get one of them wired wrong somewhere and burn something up, who knows. So we're going to do it with software. I just got back a while ago from a walk with the boss lady and Daisy. Seems like Daisy she doesn't get out much, but she wants to, so she insisted on going for a walk with the boss lady, and so I went with the both of them so I could watch, see they didn't get any trouble. And now that that's over with, it's time to go ahead and finish putting this video together. So let's just get on with it. Just my first experiment with putting a figure in the corner and making it respond to me touching the corner. As you can see, I can touch out here and nothing happens, but if I reach up here and I touch the little red square, well, make a liar out of me. You have to have a certain amount of pressure, but I print an X there to show that I actually touched the little red square. Okay, so I'm not going to go through the code for this. This is just a little primitive single step sort of thing here, and I don't know if you don't do an Arduino, if you haven't been programming them or messing with them, you can see what you're doing, your variables and things, read them back by a serial connection. Let me see if I can zoom in on that a little. There we go. So I've got this little serial screen here. You get him by clicking on the little icon over on the right hand side of the screen, and then he shows you the locations of things. See, it's showing where my finger's touching there. You see the numbers changing as I move it across the screen. And I weed those out so that the only one I have to respond to is the stuff that's inside that red square. Now that I've got that, I need to figure out printing text in exactly the locations I want it. And then I'll move on to bitmaps, because I really want to put some nice bitmaps on there and use those bitmaps to simulate my push buttons. So that's all of that. Now this is as far as I've got on the HMI. I've got buttons for up, down, decrease, increase, and stop. So if I hit the up button, it prints out a U there to show you. That won't be in the final HMI. I've just got it printing these characters to show that it works. That won't be in the finished product. Okay? You get a little right arrow and a left arrow and a D for down and a stop button, print stop. So they're all working, and I can get a value from every one of those to use to command the Arduino. And I said I'm going to show you the code, but I might just go ahead and scroll through it a little bit just for the heck of it, just to be mean. And you probably can't read any of that anyway, so but I'll just see that there's the top screen. I'll go down one screen worth, and if you can read it on your computer monitor, then you can see what I've got so far. Okay, one of the things I like is this little serial port window here, so that you can see what the HMI is doing over there. And there you are, that's what it's doing. Right now it's not doing anything. For some reason it sometimes gets a little key press. It's not a real key press, and I tried to make it stop that. It looks like I'm going to have to take the pressure up some more. You have to measure the conductivity, you know, the resistance between the X and Y wires, the X plus and the X minus wires coming out of that little LCD to get the right number to go in there. And I've been fooling with it, so that may have something to do with that. And then again, it just may not be just all that good of a touch screen. Oh well, that's enough of that. Oh, one of the things that's really screwy about this thing is for the Arduino 0, 0, the XY coordinates, 0, 0 is up here in the upper left corner. And I discovered that when I started printing letters out. And, well, they told me that too. But anyway, I discovered it was bothering me, so I had to rotate the screen. So now the coordinates from the touch screen, which is a little membrane on top of the CRT there, the little touchscreen membrane doesn't know that I rotated the screen. So his 0, 0 is still up here, and the other 0, 0 is down here. And so when you start laying out where things are at, and what area to measure and all that, it can really get confusing because you got two different coordinate systems running at the same time. Seems like they would have known how to cure that before they sold it. This is sort of a little bracket to glue into my project box to hold the Arduino still. It's got these little pins on it. This is my first attempt at printing one. And these two pins fit. Now if I get them right, they fit. Hang on. Oops, there. You can see that one pin is through. Down there, and the pin down here on the corner, he's through the hole. I don't know if you can see those things or not. Turn toward the light or something. I'm not sure how to make them really visible. You can see that one. That one fits, and unfortunately I missed about probably 3 or 4 millimeters on that one, so I'll have to go back and edit the thing and move it about 3 millimeters south. But at least it's getting closer. This is Tinkercad. It's for absolute beginners, which pretty much fits me. And there's my Arduino base. It doesn't seem to have a snap to grid, but oh, I see it now right down at the bottom. What an idiot. Okay, just learned another thing about Tinkercad. I'm going to make it snap to the grid, and I should be able to move these things around a whole lot better. Way to go, Harold. Alright, so this is what I've got so far in controls of it. I can make it turn one direction or the other. Let's say this is going to raise the spindle up. And say we want to, there's a delay in there of half a second. I forgot to cut that out. That'd burn it. Alright. Alright, so let's go ahead and make it go the other way. There. There we go, the other direction. I'll have to go in there. We don't want to delay in the spindle control, but I'll get rid of that. Nevertheless, it took a little bit to put the constants in there that will help the thing make tiny little steps that don't make as much racket as otherwise, and runs a little smoother. But as you can see, we're going in one direction. Now we're going to stop and go the other way. I'm going to have to get rid of those delays. They mess up my control of the thing. But that was temporary. Alright, so now that I've got this much done, it's on to the next little step. Well, here we are at the weekend, and I've figured out the most of the problems to control the motor, and all I got to do now is just work this into my major amount of code where I've got the touch screen and everything. This is just a simple little program here to run the pulse width modulation of the pins. Now, what the deal is that some of the digital pins will do pulse wave modulation. You can ask AVE to explain that to you. Anyway, what it amounts to is how often you pulse the pin to tell it to move. I've got a really simple little piece of code here. I had to quit using their stepper library because the little delay I was having was because it would stop. It writes for a certain amount of time out to the stepper, and then it stops, and then it writes out again. And that was what the delay was. I'd actually removed all the delays from the code. It was just their stepper library, and I never could figure out how to make their library run the thing non-stop like it's doing now. So I had to come up with my own stepper library, and I'll show you what it looks like. It's really simple. Alright, you can see from the code there that I'm using pin 7 for the output for the direction, because it's not a PWM pin, but pin 6 is. And sorry about kicking the tripod. At pin 6 I've got it set for output because he's the guy that's going to pulse the stepper controller and tell it to take another step. Okay, so I come down to the output section there in the void loop, and I write a high signal out to the pulse pin for the stepper controller, and then I wait a few microseconds, and then I send it a low signal out to it, and then I start all over again. I wait a few microseconds and I send it a high signal, and this gives me a square wave pulse coming out of the thing to the controller, and I get continuous control. So now all I got to do is just go back to the thing and fix it all up. You know, put this into the main loop of the HMI, and we'll have total control of the thing, running steady and at whatever speed we want. On the stepper controller, this light means it's got power, and the one further back means there's an error. I can't figure out what the error is in this thing, because if I turn off power to the Arduino, well, then the error goes away. And the grounds I'm using are on the Arduino, so everything's on the same common ground, and there's only 2 other pins connected to the Arduino, and they're connected the way they have to be. So I don't know what this little fellow thinks is wrong. I guess he'll just have to run with an error code. If I hadn't lost my code from 2 years ago when I was playing with this thing, I would have started out here instead of taking all this time to get here. That's frustrating. This time I'm going to try and make sure the code's saved away safe somewhere. Of course, I'll probably forget where that's at. I may actually even have the other code saved safe somewhere, and I don't know where it's at. I think the programming part's finished, except for possible future little upgrades. Going up with it. Right, down, I mean. Up direction. Stop. Go faster. Go slower. Go up. Stop. Add a little speed. Down. So there you are. That's what it looks like. I may at some later point add something over here so I can just add the speed I want in with by numbers, but I don't know that. Right now it functions pretty good, and I don't think I could possibly want it to go any faster than that. So I'll try to get the box cut open and mount this and the Arduino in a box and find a good way to put all the wires together.